All right, so we have talked about sine, we've talked about cosine. We haven't talked that much about tangent yet. What you should know about tangent is that tangent is y over x, or sine over cosine. And tangent follows the same pattern, a pattern just like sine and cosine does. Tangent of 0 is going to be 0 over 1, so that's 0. Okay, tangent of pi over 6, what I'm going to need to do is I'm going to need to do 1/2 divided by root 3 over 2, which is 1/2 times 2 over root 3, which is 1 over root 3, which is root 3 over 3. Okay, and so for pi over 6, I get root 3 over 3. For pi over 4, you should notice that these two are the same number. Anytime you divide something by itself, you get 1. When you do pi over 3, you're going to end up with root 3 over 2 over 1 over 2. I'll let you pause this now and simplify that. And when you're ready, the answer you should get is root 3. Okay, when you get pi over 2, you get 1 over 0, which is infinity or undefined. So one thing to notice about tangent, as opposed to sine and cosine never get above 1, never get below -1. Tangent is not like that. It goes all the way up to infinity, and so far, the lowest it's gone is 0. Let's see what happens when we get into the other quadrant. All right, well, it's going to follow the same snake-like pattern that a fantasy draft often follows, and so do the sine and cosine. So it goes 0 root 3 over 3, 1 root 3, infinity or undefined, negative root 3, -1, negative root 3 over 3, and then 0. And then from there, think about in tangent, in quadrant 1, it's positive. In quadrant 2, it's negative. In quadrant 3, you have a negative divided by a negative, so you're going to get a negative. And in quadrant 3, you have a negative divided by a negative, so you're going to get a positive. In quadrant 4, it's going to be negative. So in quadrant 3, you get positive numbers. So I went from 0. Now I'm going to go back to root 3 over 3. Then I'm going to get 1. Then I'm going to get root 3. And then I'm going to get another one that's undefined. You can think of this one as negative undefined, negative infinity, because I have -1 divided by 0. And then where do I go from there? Negative root 3. And I get -1 and negative root 3 over 3. And if you think of looping back to 0, you'd be on your pattern again. The graph of tangent of x has asymptotes where you have those infinities and negative infinities, so it looks kind of like this. You don't have to be as familiar with tangent as sine and cosines. Like, you won't see problems where you're asked to transform it too much, but it does transform in the same kind of way. Like if I put a 2 in there, there is a period in a tangent graph. Actually, the period is half of what it is in sine and cosine, because it has that, because it goes positive, negative, positive, negative. You cycle through all your values in half the amount of time. That's not that important, but putting numbers inside here has the same effect as it does in a sine or a cosine. So let's think and a lot of this stuff I think is maybe confusing, and if you're confused, just like forget about what you're confused about for now. Just follow along with what I'm doing. If you're taking AP Calculus next year, it's kind of important that you go back to whatever it is that's confusing you during the video and figure that out. So for question A, it says sine of x is equal to root 2 over 2. This is where I would like you to be getting to with the unit circle by this point in the year. you're thinking sine of x. What's sine? Sine is y. Where is root 2 over 2? Root 2 over 2 is here. And so you're thinking in your head, or if you have the unit circle, I'm going to draw a horizontal line to find what those two answers are, which means x could be pi over 4 or 3 pi over 4. And if I'm thinking cosine of x is equal to negative root 3 over 2, I'm thinking x is, cosine is x, right? So I'm looking for a negative root 3 over 2 on the x-axis. It's right there. Now I'm going to draw a vertical line, and I'm going to get 5 pi over 6 or 7 pi over 6. If I'm thinking tangent of x is root 3, I know that tangent of x is root 3 at pi over 3. Well, with tangent, to get the other one, you want to go across the circle, like a 180-degree rotation. So it would be pi over 3 or 4 pi over 3. And so what does this look like when we think of a graph? All right, well, if I graph y is equal to sine of x, then I get a wave. If I juxtapose those variables, if I do x is equal to sine of y, what am I doing now? I'm kind of doing the inverse function. But remember, something about functions is functions don't have two answers. So it's impossible for one input to give two outputs. That breaks down a function. It doesn't know how to do that. So you might be thinking, what is y is equal to sine inverse of x? Looks a lot like this function, x is equal to sine y. However, it stops. It only goes through, and if you think of, it would violate that. If it even took a little bit of a turn here, it would violate the vertical line test. So what is it doing? It's restricting the function to a domain that allows it to be a function. What is that domain? Well, x goes between negative 1 and 1. What does y go between? Y goes between negative pi over 2 and pi over 2. Okay, remember, this is the inverse function of what we're used to seeing. So the y values would be the x values. So if I think of this sine inverse function, x on the sine function, think of x going between negative pi over 2 and pi over 2. Well, why? Why would it go from negative pi over 2 to pi over 2? Well, look, if you think of what that is, what's negative pi over 2? Negative pi over 2 is the same as 3 pi over 2. What's pi over 2? That's that. So on the sine inverse function, we're restricting to quadrants 1 and 4. Right? And so we're restricting it to quadrants 1 and 4, but we're also making the number negative. So if, for example, I said, what is sine inverse of negative 1/2? It has one specific answer. Sine inverse of negative 1/2 is, so that's 11 pi over 6, but I would want to put negative pi over 6. And if you do this on your calculator, you would see that. This is definitely stuff you want to be familiar with for the AP calculus class. You don't need to be familiar with it for the regular calculus class. But what about x is equal to cosine of y? Same thing. If I don't restrict that, I'm going to get something that's not really a function because it violates the vertical line test. So if I do x is equal to y is equal to the cosine inverse of x, I get the same type of thing. X still goes between negative 1 and 1. Y goes from 0 to pi. So if I'm thinking about cosine inverse Cosine inverse, there's not that much trick. It's not quite as tricky. Cosine inverse cycles through all the x values going from 0 to pi. So cosine inverse is defined in quadrants 1 and 2. So for example, if I said, what's cosine inverse of negative root 3 over 2? Well, it would be 5 pi over 6. Tangent, let's see. Let's see what this looks like. X is equal to tangent of y. That's interesting. So now y is equal to tan inverse of x. Only that middle line. X goes between negative infinity and infinity. Y, what does y do? I think y goes between pi over 2 and negative pi over 2. So if you think of where's tan inverse defined the same place as sine inverse is defined. You get all the tangent values if you go in quadrants 1 and 4. So if I say, what's tan inverse of negative 1, it's going to be tangent of 7 pi over 4 is negative 1. So tangent inverse of negative 1 is 7 pi over 4, except instead of 7 pi over 4, it's going to be negative pi over 4. Let me just make sure that I have that correct. Tan negative 1 of negative 1 negative pi, oops, negative, boom. Okay. That could take some time to for you to digest, but it's a lot, and the unit circle has a lot to it. It goes deep and it goes fast, and you have to spend a lot of time thinking about how it all works to put the pieces together in your head, so that when you get to AP calculus, you won't have to spend all that time thinking about it anymore.